Welcome to chemistry classes. In this video we are going to discuss about CBSE grade 9 chapter 3. CBSE grade 9 chapter 3 part 2, atoms and molecules. In this video we have to discuss here atoms, symbols of different elements. Also we will discuss here relative atomic mass, molecules of elements, molecules of compounds. These are the things we have to discuss in this video. Okay, so here first we have to discuss about atoms. We know atoms, the smallest part of any matter, it is atom. Atoms are indivisible part of matter. Okay, also here the basic building unit of matter. Atoms are the basic building unit of matter. Three states of matter: solid state, liquid state, gaseous state. All matter made up of extremely smallest part. This smallest part is called matter. Clear? After that we have to understand here atoms are very small. Atoms are extremely small and we cannot see these atoms. Okay, atoms are microscopic. The radius of atoms are measured in nanometer. Radius of atoms are measured in nanometer. Okay. And here you have to understand 1 nanometer mean 1 by 10 raised to 9 meter. 1 nanometer mean 1 by 10 raised to 9 meter. Or you can say 1 nanometer equal to 10 raised to minus 9 meter. 1 nanometer 10 raised to minus 9 meter. So similarly you can say 1 meter equal to 10 raised to 9 nanometer. So this is the relation between nanometer and meter. 1 meter 10 raised to 9 nanometer. 1 nanometer 10 raised to minus 9 meter. Clear? Okay, next one we have to discuss here symbols of elements. Symbols of elements. Here the scientist Dalton used symbols for the elements first time. Okay, scientist Dalton used symbols first time for the elements. You can see here the figure, the Dalton used different symbols for different elements. You can see here. Okay, and here in modern periodic table, in modern system, here the symbols of elements are depends on their name. First letter or first two letters in English name. For example, here carbon, the symbol of carbon C. The symbol of calcium Ca. So in modern periodic table, in modern system, the symbols of elements depends on first letter or first two letter. In carbon, first letter. Okay, in some case here calcium Ca. So when you are writing, if there are two letters, first letter you have to write capital letter and second letter should be small letter. Okay, calcium, here calcium, C capital letter and A small letter. In case of calcium there is only one letter, only first letter. This first letter we have to use here capital letter. Hydrogen, another example, hydrogen. So first letter here H, so we have to use here capital letter. So the symbols of elements depends on their English name, and here we will use first letter or first two letter. If there is two letter, first letter capital letter, second one small letter. Okay, and if there is single letter we have to use capital letter. Also the symbols of elements depends on first letter and second letter. Not second letter, the letter which appear in the name. See here one example, chlorine symbol Cl. So here Cl, first letter and not second letter. Here first letter C, second letter H. So the symbol of chlorine not CH, here first letter C, second letter here this letter it appear in the name but not in second letter. You understand? So here the symbols of the elements are coming first letter and next letter it will appear in the name. Okay, here I told you here first two letter calcium, this is the first two letter, okay, Ca, but in this case in chlorine not first two letter, first letter and another letter it coming in the name, not maybe it will be third letter or fourth letter, okay, so not mentioned here first two letter, first letter and next letter will be in the name, okay, example chlorine. Another example zinc. So here first two letter mean zinc and I, the symbol of zinc not Zi, here Zn, first letter and another letter will be in the name, not first two letter. You understand? Not first two letter, first letter and another letter it will be in the name, okay, Zn, zinc, okay, and here chlorine, Cl. Also here third case, symbols of the elements also depends on their name in Latin, German or Greek. Okay, the symbols of the elements depends on their name in Latin, German or Greek. For example, look here, iron Latin name ferrum, so symbol Fe. Okay, first letter capital letter, second letter small letter, iron, ferrum. Similarly, sodium, natrium, Na. Potassium, kalium, first letter K. So these are the different way to represent symbols of the elements. Symbols of the elements depends on their name in English, okay, also their name in Latin, German or Greek, okay. Also here we can use first letter or first two letter or first letter and another letter it is in the name, okay. Okay, next one we have to discuss here atomic mass. We discussed already atoms are microscopic and very small, so it is very hard to measure its mass, okay. That's why here scientists used 1/16th mass of an oxygen atom, naturally getting oxygen, and its mass 1/16th mass of naturally getting oxygen used as a standard unit, okay. Look here, you know, to measure mass we usually using a balance. We use a balance, okay. You want to measure 1 kilogram sugar or 2 kilogram sugar, or you want to measure something, okay. So we will use here 1 kilogram weight or 2 kilogram weight, and we will compare the mass of sugar, or you want to measure mass of tomato or vegetable or anything. So we will measure its mass by comparing some weight, okay. So here we cannot use this type of weight. We cannot use gram or kilogram or milligram weight to measure mass of atoms, because atoms are extremely small. We cannot measure in gram, kilogram, milligram. We cannot use this, okay. So here we will use another unit. It is called AMU, atomic mass unit, AMU, or we will say unified mass, okay. So we cannot use this type of unit, gram, kilogram, milligram. This type of unit we cannot use in case of atoms, because atoms are extremely small. So we will use another type of unit. It is called AMU or U, okay. AMU mean atomic mass unit, or U mean unified mass, okay, this type of unit used. So I told you here we cannot use 1 kilo, 2 kilo, this type of weight we cannot use, okay. That's why here scientists initially used a weight, it is naturally getting oxygen, okay, and here 1/16th part of oxygen used as a standard weight, and weight of different elements comparing with this unit. We want to measure mass of hydrogen atom. So we will keep hydrogen here and it will compare its mass, comparing with 1/16th oxygen. Okay, you know oxygen, its mass is 16. Mass of naturally getting oxygen, it is 16. So when you take, so naturally getting oxygen mass is 16. When you take its 1/16th, so what will be the answer? It is 1. Okay, so here 1/16th naturally getting oxygen mean its weight is 1. So we will compare the mass of different elements with this mass. Clear? Here scientists used naturally getting oxygen. Initially scientists used naturally getting oxygen because this oxygen react most of the elements and form a stable compound. Here you have one question. Why scientists used oxygen atom, naturally getting oxygen, why not use other elements? So here this oxygen reacting with most of the elements and form a stable compound. Second one, the atomic mass unit, the atomic mass obtained by comparing with 1/16th oxygen is getting a whole number. In most case, it getting a whole number, not a fraction. Okay, these are the two reasons scientists used oxygen to get atomic mass. Clear? So here first reason, oxygen reacting with most of the elements forming a stable compound. Second one, the mass obtained by comparing 1/16th oxygen, it getting a whole number, not fraction, it getting a whole number. These are the reason to choose oxygen as a standard unit. Clear? Okay, so here we discuss initially scientists used oxygen. Okay, 1/16th oxygen, naturally getting oxygen used as a standard unit. But later onwards, 1961, in 1961 scientists chose carbon-12 isotope as a standard unit to measure mass of different atoms. Here scientists used carbon-12 as a standard unit because this carbon-12 isotope contain exactly 6 proton and 6 neutron. Okay, so mass of carbon-12 isotope, its mass is exactly 12. It contains 6 proton and 6 neutron. That's why scientists chose here carbon-12 as a standard unit. Okay, so here we want to measure mass of one element. So this element, mass of this element will be comparing with 1/12th mass of carbon-12. Okay, 1/12th part of carbon-12. Okay, and it will comparing with this element. So after measuring one element, its mass is 1 AMU. 1 AMU. We measured mass of one element using this system. Here we will compare mass of one element with 1/12th part of carbon-12. Clear? So after getting this, we got it is 1. It is 1. So it's mean 1 atomic mass. This 1 atomic mass mean 1/12th mass of an carbon-12 isotope. Look here, carbon-12. I told you carbon-12 mean its mass is exactly 12. because it contains 6 proton and 6 neutron. So here we will take 1 by 12th part of carbon 12. So carbon 12 means its mass is 12. So we will take 1 by 12th part. 1 by 12th part of carbon 12 means it will be 1. Clear? So here we got 1. So it will be 1 AMU, 1 atomic mass unit. So 1 atomic mass unit means its mass is 1 by 12th part of carbon 12 isotope. Okay, 1 atomic mass unit is exactly equal to 1 by 12th part of mass of an carbon 12 isotope. That is 1 atomic mass unit. Atomic mass unit, now it is called unified mass. Okay, unified mass. Here you can see here in your textbook it is given here one fruit seller, he don't have any weight to measure mass of fruits. Okay, he know one watermelon, its mass exactly 12. Okay, there is one watermelon, its mass is exactly 12 kilogram. Okay, and he cut it to 12 small pieces. One watermelon, its mass 12 kilogram. He cut this watermelon equal 12 part. So when you take one piece, its mass is 1 kilogram. Okay, and he used this piece, watermelon piece, to measure rest of the vegetable. You understand? Similar thing, similar concept we will apply here. Okay, I told you we cannot use kilogram, gram, milligram, this type of unit. We cannot use measure of atom because atoms are exactly small, microscopic. We cannot see it. Okay, so we cannot use this type of unit. So we know the mass of carbon, actually it is 12 unit, not 12 kilogram, not 12 gram, not 12 milligram. We will say 12 unit. Okay, 12 unit. 12 unit mean it contains 6 proton and 6 neutron. We will say the mass of atoms based on the number of protons and neutrons. How many protons are there? How many neutrons are inside the atom? Based on this, we will say the weight of atom. Okay. So carbon 12 isotope. This type of terms we will study more details later. Now you understand. When you take carbon 12 isotope, there is 6 protons, 6 neutrons. So it is exactly 12 unit. So when you take carbon 12, when you take 1 by 12th part of carbon 12, it will be 1 unit. And this 1 unit we will use to measure rest of the elements. Similarly here, watermelon, it is exactly 12 kilogram. We cut it to small pieces, equal small pieces, and take one piece, it is 1 kilogram, and this small piece used to measure mass of rest of the vegetable, rest of the fruits. Clear? So similar concept we will apply here. So this is atomic mass unit. Clear? Okay, also you can see here different elements, their masses based on this measurement. Here we can see hydrogen, it is 1 atomic mass, hydrogen 1 atomic mass unit, oxygen 16, magnesium 24. Okay, you can see here different type of elements and their masses based on this measurement. Okay, next one we have to discuss here molecules. Molecules are group of 2 or more atoms. 2 or more same or different type of atoms. And these atoms are chemically joined together. There will be a chemical attraction between this atom. This type of substance are called molecule. Okay, see here example for molecule. Here 2 hydrogen atom. 2 hydrogen atom joined to form H2. H2 means 2 hydrogen atom. These 2 hydrogen atom, there will be a strong chemical force. chemical force. Chemical force mean there are different type of force of attraction between atoms. Okay, so this is chemical force, and there will be a chemical force between atoms, and this is very strong force of attraction, and this group of atoms are called molecules. Okay, so here you can see H2, two same type of atoms forms molecules, and see here another molecule, two hydrogen atom and one oxygen atom join to form H2O. H2O mean two hydrogen and one oxygen atom join to form molecule. There is strong force of attraction between hydrogen and oxygen. Okay, so here group of atoms mean here this group of atoms mean atoms are joined by chemical force. Okay, this type of group of atoms are called molecule. Molecule mean same type of atoms forms molecule or different type of atoms forms molecule. Okay, to make molecule at least two atoms must be there. Two or more same or different type of atoms forms molecules. Clear? And here, look here we know hydrogen it is element. Hydrogen it is element, and H2 mean this is the molecule of element. H2, O2, N2. Okay, these are H2, O2, N2. These are molecule, and these are molecules of element. Molecules of element. And see here H2O. H2O mean water molecule. NH3 ammonia. Okay, these are molecule and these are compound. These are compound. So molecules of elements and molecules of compound. Molecules of elements mean there are same type of atom. Molecules of compounds mean there are different type of atom. In each case, atoms are joined by chemical force, strong force of attraction. Clear? And here we have to understand here this molecule shows similar properties of their substance. For example, when you take one water molecule, this one water molecule shows same properties of water. You have one beaker, full of water. Okay, this is water, and you take one water molecule. This one water molecule and this beaker of water both have same property. Clear? You take one hydrogen balloon, it contains hydrogen gas. Okay, there is full of hydrogen gas, and you take one hydrogen molecule. So this hydrogen molecule and this hydrogen gas both have same properties, not different properties. So they have same properties. So here you can say the molecule shows same properties of their respective compound or respective element. Okay, here this molecule shows same properties of elements. This water molecule shows same properties of their compound. Clear? Also here we have to understand these molecules are independently exist in the nature. Hydrogen molecule, it will exist in the nature. Okay, water molecule, it will independently exist in the nature. It will available in the nature. Okay, next one we have to discuss here molecules of elements. We already discussed molecules of elements and molecules of compounds. Molecules of elements mean molecules of elements, example hydrogen, oxygen, nitrogen, etc. These are example for molecules of elements. Molecules of elements mean it contains same type of atoms. Same type of atom. Hydrogen molecule, two hydrogen atoms, same type of atom. Okay, and oxygen atom, oxygen molecule mean two similar oxygen atom, two same type of atoms joined to form molecules of elements. Here you have to understand in noble gases mean some elements, helium, neon, argon, krypton, xenon. This type of elements are called noble gases. These elements are called noble gases. These elements do not make any type of molecules. They are freely exist in the form of single atom. Okay. Here oxygen in the nature, it will exist in the form of O2. Two oxygen atom join to form O2 molecule, and in atmosphere oxygen exists in the form of O2, hydrogen H2, N2, F2. Okay, sulfur exists in the form of S8, phosphorus exists in the form of P4. Four phosphorus atoms join to form P4, and it will exist in the nature in the form of P4. But this type of gases, all these are gases, helium, neon, argon, krypton, xenon, this type of elements exist in single atom, okay, single atomic form, and they do not make molecule. Clear? This type of molecule, oxygen, hydrogen, nitrogen, these are two atoms joined to form molecule. Here you have to understand, I told you oxygen in the atmosphere, oxygen exists in the form of O2. Also you know ozone layer. Ozone layer, you heard before, ozone layer. Ozone layer means three oxygen atom joined to form O3. Three oxygen atom joined to form O3, and this is O3. This is molecule. This is molecule of molecule of an element, because it contains same type of atom, three oxygen atom only. Okay. So ozone also molecule, it contains three oxygen atom, and here you understand noble gases. Noble gases mean helium, neon, argon, krypton, xenon. Also there is one more, radon. This type of elements, they do not make molecule. Okay, and here one more point you have to understand, atomicity. Atomicity means number of atoms in a molecule. Number of atoms in a molecule of an element. It is called atomicity. Look here, oxygen. Oxygen. Here oxygen. This is one molecule. It contains two oxygen atoms. So here atomicity 2. Okay. Similarly here N2, F2, Br2, I2, Cl2. This type of elements are. This type of element contain two atoms. Okay, all of them contain two atoms. So you can say here atomicity 2. This type of molecules are called diatomic molecule. Diatomic molecule mean molecule which contain two atom. Molecule which contain two atom. Okay, that is diatomic molecule. You understand? And here atomicity 4, here atomicity 8. Okay, so that is atomicity. Clear? Okay, next one we have to discuss here molecules of compounds. Molecules of compounds mean atoms of different elements. Atoms of different elements chemically join to form molecules of compounds. Atoms of different elements chemically join to form molecules of compound. Example, water. In water, different elements, atoms of different element, hydrogen and oxygen, different element, they will join chemically in a fixed proportion. You have to remember this. Different atoms of different elements chemically joined in a fixed proportion to form molecules of compound. Fixed proportion mean, look here, water mean, we know H2O. This is water. H2O, it contains hydrogen and oxygen. Here you have to know the relative atomic mass. Atomic mass of hydrogen 1. Atomic mass of hydrogen 1. Atomic mass of oxygen 16. H2O, 2 hydrogen and 1 oxygen. So here here the ratio of hydrogen and oxygen, the atomic mass ratio of hydrogen and oxygen, 2 hydrogen here, so 1 times 2. Here mass of hydrogen will be 2. Look here, 1 hydrogen mass is 1, 2 hydrogen mass is 1 times 2. So here 2, oxygen 16. So the ratio of mass of hydrogen and oxygen 2 is to 16. You can simplify this by dividing 2 both sides, 1 is to 2. So the ratio of hydrogen and oxygen in water, it is 1 is to 8. I will repeat once again. Here mass of hydrogen 1, mass of oxygen 16. Here 2 hydrogen, so 1 times 2, 1 times 2. So here 2 and mass of oxygen 16. When you simplify this by dividing 2 both sides, it will be 1 is to 8. Clear? See here another example for molecule of a compound NH3. Ammonia, it is ammonia, its formula NH3. The ratio of nitrogen and hydrogen. The mass of nitrogen 14, mass of hydrogen 1. So 14 is to 3. Here 3 hydrogen, 1 times 3, here 3, mass is 3. So the ratio of nitrogen and hydrogen 14 is to 3. Carbon dioxide, mass of carbon 12, oxygen 16, 2 times 16, 32. So the ratio of mass of carbon and oxygen 12 is to 32. 12 is to 32. Okay, when you divide this, when you divide by 2 both sides, it will be 6 is to 16. 6 is to 16. Again you divide both sides with 2, it will be 3 is to 8. So here the ratio of carbon and oxygen in carbon dioxide 3 is to 8. Here mass of carbon 12, oxygen 16, here 2 oxygen, so it will be 32. Okay, after simplify this you will get 3 is to 8. Here you cannot simplify this again. Here odd number and even number, you cannot simplify this again with a common number. Okay, so here we discuss molecules of a compound. Molecules of a compound mean atoms of different elements are chemically joined in a fixed proportion. That is molecules of compound. Okay. Next one, here we have to understand here ions. Okay, last point in this video we have to discuss here ions. Ions mean charged atoms are called ions. There are 2 different charge we know, positive charge and negative charge. Okay, look here, you know in elements, there are 2 different type of elements, metals and non-metals. Metals and non-metals. These are the major classification of elements, metals, non-metals. Generally, metals form positively charged atom. Metals form positive charge and non-metals form negative charge. Okay, elements 2 type, metals and non-metals. Metals form positive charge, non-metals form negative charge. Okay, there is one exception case. Hydrogen is non-metal, but hydrogen form positive charge. Hydrogen form H plus positive charge, but hydrogen is non-metal. It is one exception case. Generally we will say metals form positive charge, non-metals forms negative charge. Positively charged atoms are called cations. Okay, positively charged atoms are called cations. Okay, example for positively charged atom, Na plus, Ca2 plus, Al3 plus, etc. Okay, here plus 1 charge, here plus 2 charge, here plus 3 charge. Here why here plus 1? Look here. Here it is Na plus. Na plus. Na plus mean it is equal to Na plus 1. Na plus 1. No need to write Na plus 1. Na plus mean Na plus 1. No need to write it. Generally Na plus 1 we will write like this, Na plus. Na plus mean positive 1, plus 1 charge. Okay, you understand? So here Na plus, Ca2 plus, Al3 plus, these are examples for positively charged metal, positively charged atom. Positively charged atoms are called cations. Okay. Why here plus 1 charge and here plus 2, here plus 3? Why they have different charges? We will discuss later. Okay. Now you understand positively charged atoms are called cations. Similarly, negatively charged atoms are called anions. Okay. Cl minus, O2 minus, N3 minus. These are negatively charged atoms. Negatively charged atoms are called anions, and positively charged atoms are metal, and negatively charged elements are non-metal. Okay. Here one more case we have to understand here, ionic compounds. Ionic compounds mean positively charged metal and negatively charged non-metal react together form ionic compounds. Ions forms ionic compound. Compound, we know sodium chloride, sodium oxide, magnesium sulfide, these are compound. Here magnesium here positive plus 2 charge, sulfur minus 2 charge. So two oppositely charged atoms react together form ionic compounds. Generally you understand ions, charged atoms, positively charged atom and negatively charged atoms react to form ionic compound. Example here, sodium chloride, sodium oxide, magnesium sulfide. These are example for ionic compounds. Okay. So these are the things we have to discuss in this video. Okay. You can review the video once again. Okay. So these are the things. Next part we will discuss next video. So thank you for watching this channel.